Hey guys, I'm gonna start to solve a medium level problem. Subarray sum equals k given an array of integer nums and an integer k. Return the total number of subarrays whose sum equal to k. A subarray is a contiguous non-empty sequence of elements within an array. So nums 1, 1, 1, k is 2. So 1, 1, first this 1, 1, and then this 1, 1 will be the answer. So the output is 2. Here 3, this is 3, and this is 3, right? And thinking about some case like something like 1, 2, 1, 2, and then if we need 4, then from here is smaller than 4. From here, in the case we need to add more, smaller than 4. Let's add more, right? Oh, this is 4. Good. Then do we have another from here? So decrease the lower bound, and then let's try to add. Oh, this is bigger. Then try to make the lower bound, increase the lower bound, and then since this is smaller, we can add one more. Oh, this is the one, something like that. So I think this is one of the way to solve this problem. Well, actually, I thought about this solution yesterday, not right now. So it's kind of cheating, but let's do this. So we have two index starting, and then we have this, and then while I don't know at this moment clearly, and then we have count, which is 0. Yeah. So we're gonna return count here. So, and then we'll have some kind of sum. Sum is initial 0. So let's so initially let's put it nums dot 0. So here nums is always bigger than 0. So yeah, so maybe we can have some condition like if nums dot length size equals 1 and nums dot 0 is k, can return 1. So here nums is 0. So let's say that if sum is smaller than k, what we're gonna do is we're gonna increase the end and then add nums and into it. Else, first condition should be like if sum equals k, then what can you do? You can increase the count, and then try next by increasing the start. then if sum is smaller than k, we have to do this. Actually, this means that some nums start, then do this. So here start must be less than nums dot size n, and this must be nums dot size 2. So while we have this, and then else, which means sum is greater than k, what we want to do is we're gonna do this, right? So initially I guess this might not need it, but let's try to think about this one. For this one and case 1, and here case 2, here case 4, right? And we can think about this too. Here when 1 is this is exactly this case, so we'll return 1. Yeah, so correct. So in this case initially this sum is 1, right? Start is 1 and end is also, I mean, 0th index. So this is this case, so we'll increase end, so end will be here, and then we're gonna add this 2 into sum, so sum is now 2, and then in the next round, sum is 2, right? So we're gonna increase the count from 0 to 1, and then we're gonna increase the start from here to here. So now start and end point here, and then we're gonna subtract this. So sum is now 1, right? So here we're gonna go another loop. So now sum is less than this, so we're gonna move here and then add 1 to, so sum is now 2, and then in the next turn sum is 2, so we're gonna increase the count 2, and then start will be increased from here, right, to here, to check the next one. And then in the next round, since sum is now 1, sum is smaller, so we're gonna do this, and then now end is more than the end is equal to the size, so this will end, we can count 2. Then here, so first 1, 2 is the same as before, so now we have start and end pointing to, count is 1, and then 2 is this case, so end will be here, and then it turned out the sum is now 5. So here start will be plus plus, and then num is removed, so subtracted, so now sum is 3 and start is 3, end is 3, and then next turn, this is 3, yeah, good. So we're gonna increase the start, and now start is the and then the thing is, let's say another case like in here, yeah, so you're here, and then sum is 2, but we increase the start, and which means that start is now more than end, which does not make sense. So we need one more case condition here. If start is more than end, and we have to move end, and then we have to reset nums to end. So now, yeah, like this. And then yeah. So I think this will work. Run, compilation error, count, okay, wrong answer, -1, k is 0, but output is 0, expected 1. This is let's do this. Here, if st equals st and then else if st okay. Then -1, okay, 0. So first, the thing is, I was thinking that k is all positive, but it seems like k is negative too. So here -1 is smaller than k. So with this logic, smaller. So we're gonna try to add more, and then it is now -2. So we're gonna try to add more. So here 1, but here still -1. So we're gonna try to add more, and then it will, yeah. So this logic may not work with negative number. So this is wrong. Actually, it works only for positive number. Okay. Great. If I work it with a negative number, and then negative number, if we add more and more, negative number will be smaller and smaller. Oh shoot, I haven't thought about this. Yeah, I haven't thought about this. This one is important. Okay, this one is wrong. So here is minus 2. We said this, minus 2. And then if this is negative, the other way around. Oh, there's two way actually. It could be add. It can add here, or it can remove here. So if this is minus 2, and if k is minus 2, this is minus 3, and since this is minus 3, what it can do is you try to remove this or try to add this. So this way does not work with negative number. Right. We might need some different way of thinking, not a solution like this. Okay, so let me try the other way. K is huge number, very long number, so okay, some other way to solve this. Is there any other way to solve this? So we don't want n square time complexity. And the length of this is pretty huge. So one way to think about this is that we can build the same size of vector like this, and then I don't, but okay, let's just sums, and then the size is nums dot size. Then what I can do is that for auto nums not auto to I plus plus sums I equals sums sums 0 nums 0. So let's start from the I minus 1 plus nums I. Yeah. So sums will contain the addition of nums at, so sums k actually contains the addition of the sum of the num from 0 to k, which means that for each k, like int k, k1 k is sums size k, for each k you can run L kt from k minus 1, and then t is 0, t minus minus. So what we want to do is, if some k minus t, so int s this one, and if s k oh, I don't like this solution. If k minus s, no, if sums k minus, oh, s, this is s, k, then this will take forever. Yeah, this will work, but not very efficient. Not very efficient, but this is very inefficient. But the answer is wrong. Haha. Because last case, when k is 2, this k 1, so k2 minus k1 is s, right? Why the output is 0? Same. These are same. So when k is 2, 0, 1, when k is 1, sums k is 3, and then here let's say that T2 T1 T2 T2 T1, right? Time limit exceeds. The 30 minutes is over. Wrong answer. And wrong answer. So here Since this start from 1, I mean we don't count 0. So maybe we have to start from 0. That way, in that case, this won't run. Okay, time limit exceeds. So, yeah, just as I expected, time limit exceeded happened. So let me stop here and then try to fix this after watching editorial. Okay guys, bye.